All right, what's up, y'all? Guess we're back with week 2. You know, um, shit. Yeah, guess we got another few more weeks with clients. So today's client is going to be and so we'll call him R for the sake of brevity. But yeah, he's going for an L3 to L4 conversion. And we're hopefully going to try getting him a place at Google, Facebook, or Amazon. And most likely that he's only going to be able to get the L4 at Facebook, given his background and his arrangement. So right now we're going to just see where he's at, if he's made any progress since last time. Just to quickly recap, where he what issues he had was really to run through the whole idea before he writes the code for it, and do like an overall brain dump of what he is trying to do, and to keep the explanations and the ideas very, very simple. And so we're going to see today if he has actually done that. We're going to see if he's actually gone ahead and done all the homework that I've asked him to. And the point really today is to make sure that he actually has spent the time practicing towards what we've been talking about. It's not so much important that he solves the problems. What's more important is that he's actively trying to implement what we have been discussing. So hopefully there are people who are like just tuning in. Hey, what's up? My name is Edbert. I am an ex-Apple senior engineer I'm also an Android engineer, and I help people get really good at the coding interview and in the process become better engineers. So if you guys have any questions for me, feel free to ask before we begin. We'll begin at sometime around like 8 p.m. PST. So yeah, if you guys have any questions, holler at me. In the meantime, I'm going to be going through all the news here on Hacker News. So hopefully something here will be interesting. I deleted data from production. Okay, this looks actually pretty interesting. And then Hertz orders 100,000 from Tesla. Okay. Let's see what this guy did. Facebook, the last few weeks have been busy with some huge downtimes. Yep. GitHub had an outage because they accidentally removed data from primary database and the backup wasn't working. Failover. Yep. We are not hosting, but we are still human. We are not protected from destroying our beloved platforms in a blink. Correct. This is an educative and therapeutic post in order to show you that something normal and to say it aloud. If you understand French, you can also relate. Okay. The time when he deleted all the users. I was setting up a Hadoop cluster for a company, a small size cluster with less than 10 nodes. Okay, sure. It is his first setup. He got the day I got the partitions too big or too full error in the name node. Big deal. The cluster was down. Okay, sure. Small throwback. At the time, I just graduated and have experience with Linux administration, but only to deal with personal websites and blogs. Okay, sure. So you was doing everything that everybody was doing. Yeah, let Stack Overflow take the wheel. Yeah, I think that's pretty much what everyone does. But then there's like, like we've said before, just because you can Stack Overflow something doesn't mean that you are capable of engineering a solution. Okay, so he started moving big folders, and then so he created folders in partition and then symlinked them. Sure. Once I removed the user folder, I got in big trouble. Yes, user means removing all Linux binaries. So yeah, you're out. So basically, with some creativity, you can get back the binaries, but the masterpiece is the sudo command. Okay. So, but the revert plan didn't work. That's when I asked for help. The reason I did not ask help earlier was because the IT team needed ticket to work on topic, and I wanted to fix the issue faster. Okay. Yeah, so I guess that he just wanted to take matters into his own hands and just kind of figure out what the heck was going on there. Sure. In the end, it wasn't a big issue. If he asked for help earlier, he could have gotten it better. Yeah, so basically, he was just moving the files around and then symlinking them, but then ended up just kind of hurting himself. So that kind of makes sense. Slash data. All right, woke up, look at Slack, nothing ran. The whole system was down. All pipelines were broken. Sure. How the data was missing. You were responsible for deletion. Yep. It's Sunday morning that I've lost about 3 terabytes of data, and the data pipelines have stopped working because Friday I ran for no reason. Okay. Wow. Okay. He deleted everything off the DFS. Okay. Okay, so he got back to 60 to 80% of the data back. Wow. Lucky for him. Terraform destroy under production. Okay, so basically, blah blah blah. I think the mistake here, or at least the lessons learned, is that everyone's human and this can happen to anyone. So create a goodwill environment. Don't break under the pressure. Stay easy to say and hard to do. Sure. Never blame the responsible, because you might be responsible. That totally makes sense. This can happen to anyone, and anyone is able to. Anyone is like, this could be you next time, and you don't want to feel like shit. But then again, I'm of the opinion that you should blame some, at least hold the offending party accountable, so that way they never really do this again. So yeah, let's. I would say at least keep some of the responsibility there. Yeah, avoid copy pasting from the internet if you don't understand the side effects. This is a big one I would really highly preach. This is really no different than really copy pasting whatever you see on LeetCode for an interview. There's no way we would ever accept anyone who did that for a LeetCode interview, and chances are if you do that for LeetCode, you do it for coding. And if you copy paste shit you don't understand, you are actually like gonna be like this guy and actually break some shit. And what happens if you delete production? Haha, wow. Like, why'd you break production? Because I copy pasted code I didn't understand. So go figure. Let's see what else is here. The strangely difficult problem of drawing a box around text. Sure. What else? What else is interesting? Okay, third quarter results. Okay, maybe I'll read that later. Actually, no. Let's read that. Okay, 3 months ago. Okay, this is quarter over quarter change. Their revenue from ads increased. Wow. Okay, year over year increase. Holy shit. Their ad revenue increased so fucking much. Jesus Christ. 195 year over year. Damn. Okay. Yeah, 33% year over year revenue. I don't know. I don't know about this. It's like, I feel kind of weird about it simply because, advertising revenue is just one of those things I cannot see just going up forever and ever. It's really weird. Like, maybe it's just because I'm not a marketing guy, but like, this is the kind of a business I don't actually quite understand that well. Control costs and expenses up 38%. Okay, fair. I guess it's remotely onboarding people, and trying to do all this shit. Income from operations 30%. Yeah, so everything is up. Everything is up 30%. Costs and expenses are up 30%. Everything's up 30%. So I would not be surprised that if Facebook's growing, but then but their margins are not actually as high. But then again, their earnings per share is actually 19%. So I guess it's actually kind of high. So I'm interested. Daily active users 6% year over year to generate a 30% increase in advertising. What the fuck? This is actually kind of nuts if you think about it. For 6% more users, you get 30% more advertising? The hell? Oh shit. Okay, they did a share buyback. Wow. And they still think their capital, they still think their fucking stock is underpriced. Okay. Wow. I guess now's a good time as any to own Facebook stock. Although personally, I'm still a hold up in Apple, but I guess like management really likes their shit. Headcount is 68,000 people. So they've been hiring like crazy, increase of 20% year over year. No wonder. So that's why their capital expenditures have gone up. Headcount has increased as well. They really, really want this shit to go wild. So okay, let's answer some questions. Hey Edbert, I really liked interning at national labs, but my fear is I might be missing out on company internships. How do people view experience in maintaining open source scientific software? Like, honestly, it depends on what your future looks like. If you're trying to go for something like academic or in the military, then maybe open source software is okay. But for the most part, I would say 80% of the industry really likes seeing that FANG brand name on your resume. But the thing is that you're talking about internships. So at this level, it really doesn't matter. Like, you could have an internship at NASA, you can have an internship at Facebook. As long as you have some kind of recognizable technology company on your resume, you're pretty good, to be honest. I mean, definitely there is more weight towards FANG, but, overall, you're not going to be in a bad position. So if you enjoyed your internship and they gave you a return offer and you really liked it, I would still say go for it, only because like, um, you know, they may give you a better offer coming out of school, and you may have some different doors available to you. Not the end all. Facebook, Google, all those companies are not the end all. You have an entire career in front of you that you can go to at any point in time. What matters is that you really have the right people to learn from in the beginning. So as long as the people at your lab are very, very dedicated to their job and really, really like it and are willing to teach you, and you learn the right things, then it's all gravy, man. That's the way I think about it. Anyway, I think it's about time for what's it called? The client to come in. So let's meet up with him and see what's up. Holy shit.
Recording in progress.
All right, let's see if he shows up. Okay, he says he's gonna be there in a few minutes. I guess that's kind of good news. I can just get some water, maybe. Yeah, man. No problem. Just remember, focus on like learning the right things and thinking like a good engineer. The money and everything else will come afterwards. Like you have your entire rest of your career to hit Fang. Yeah, let me get some water. I'll be right back, guys. All right. Okay, I'm back, guys. Got some delicious water from my shitty pipes. All right, let's see what else they got here. Um, yeah, I guess to recap the Facebook thing, I would say like look at these. The big one that stands out to me is really the share buybacks. Actually, I think this is really really good. Facebook's growing for sure. They increased headcount by a lot, but the question now is like, for me, what kind of value is Facebook driving? And for me, 30% year over year for Facebook is like it's not impossible, but it's like it's hard for me to justify the value of that unless they literally start like growing in like places that aren't like the Western world. The way I see it is that you have two things. You can squeeze more users for more value, or you can expand elsewhere. It's almost infinitely easier to expand elsewhere. So I think Facebook, as long as they can expand, they're fine. But it's like there's only a finite amount of growth available in the world. So I'm kind of like iffy on the value that um, they can provide. So looks like he entered. Let's see what he has to say. Hey man, what's up?
Hey, bud, how you doing?
Hey, doing good, doing good. Yeah. So I see that with the we checked in on Saturday. You said
Yeah,
you went to do the recursion for leak code because of your online assessment that was coming up. And that you were
yeah.
almost done with the breadth first search, depth first search stuff. How have things gone since then?
I think things have been okay. I just got a little overwhelmed when I was like, because I was prepping for the Amazon OA and I was going through like some of the questions that people had, like people were talking about in the discussions
Yeah.
on leak code discuss section. So I was just kind of trying like a couple problems, and I guess like trying like a couple problems like in like a short time with like different patterns, I was like a little overwhelmed. But overall, like I think the OL went okay today. They came back and said like we're moving forward with the next steps. So I'm gonna have to schedule a call with the interviewer and see what to do next. Because I like it should be a phone interview, but then like in the email she also sent me like a bunch of prep and like information regarding on-site. So I don't know like what is the plan. So I'll have to talk to her to see what's up.
Okay, are they sending you
But yeah.
straight to on-site or what?
I don't know. I haven't talked to her yet. She just said like she just sent me the email and like told me like to answer a couple of things. But then she also sent me like a lot of information regarding like on-site as well as like links to like some on-site prep sessions. So I don't know like what she has in mind because I haven't talked to her yet. Previously we were just talking through email and then she just told me to do the online assessment. And then now that that's done, she wants to schedule a call to talk about the next steps. So I don't know yet, but I'll let you know once I find out.
Okay, but at least you passed it. That's the good news.
Yeah.
Great.
Yeah.
Okay, cool. Did you feel any of the things we talked about kick in and help you for the OA?
Yeah, I think like just like being able to like not jump in and just like run through problems and like examples and actually walk it through what I plan to write helped. But it was just like when doing like the practice for the OA, I was just like running into. I feel like I get stuck a lot when it comes to like 2D arrays, like doing buffer shits, BFS on those and stuff.
Okay, well, let me write this down. 2D. You're stuck with 2D array. You said.
Yeah.
What about breadth first search, depth first search? Are you still struggling with that?
I guess it depends on the context. In the context of trees, I feel a little more comfortable. But in the context of like arrays, I'm still struggling a little. So I'm hoping to do more of the array problems on EPI.
What do you mean array problems for DFS, BFS, or are those two things different?
Just like being able to consolidate my thoughts when I'm like going through like array, like simple like 1D arrays or like 2D array problems. I just have to like sometimes I feel like I take longer on those than I do on other problems.
Yeah, arrays can be very tricky, but I think the core of what we were just talking about was like make sure you get the ideas out, and if that's working well, then we can kind of move on to the next step, which is like thinking objectively. Like once you have the ideas, it's how to aim the ideas at the right area. So let me actually find an array problem that I think is going to be good for this.
Okay.
Okay, this might actually be a good one.
Okay.
Cool. Well, actually, this isn't like so much a typical array problem though. Oh wait, no. This one could actually work. Hold up. Okay, let me bust out the timer, and then we'll get started.
Okay.
Okay. Yeah. Okay. You're on the sheet, right?
Yeah, I'm on the sheet.
Okay, so we'll get into 2D array problems later, but let's do this one first. So, given an array A of integers, return the number of non-empty subarrays that have a sum divisible by k. So, what does this mean? So, let's say I gave you an input of 4, 5, 0, negative 2, negative 3, and 1, right? And then a k of 5. Well, there are 7 different subarrays where the sum of all of those subarrays is divisible by 5. So, for instance, let's pick a 1. 1 with 5. 5 is divisible by 5. 5 plus 0 is divisible by 5. And then, 5, 0, negative 2, negative 3. That's going to sum up to 0, and that's divisible by 5. So, does the question I've asked make sense?
Yeah, it makes sense.
Good.
Okay. So by non-empty, I just assume that means it has to have at least one element in there. Okay. Okay, so looking at the problem... What's up?
I think I might have given you the dynamic programming one. Uh-oh. Now let's see the solution. I mean, yeah. Oh shit! I gave you a dynamic programming problem. I was looking at the other one. My bad. My bad. Hold up. Don't do this problem. This is dynamic programming.
Okay.
Yeah. Like now I'm looking at it. Oh shit. Okay. Good. Sorry. Let's try another one. That's on
Okay.
me. Okay. Um. I mean, we could always do the rotated 2D array if you like. If you want to try that one.
I feel like I would get stuck a lot, but
Okay. Perfect. Perfect. Then that's a good one. Because if you get stuck, that's perfect for me because that means that you know there's stuff for us to talk about. Okay, so
yeah. Okay. I feel like I've done it like once, but it's like a long time ago, and I knew like I struggled a lot with it. So yeah, we can go ahead and try it.
perfect. Yeah. Let me find the copy of that problem.
Okay.
Okay, and let's start. Okay. So write a function that takes in an input n by n 2D array and rotates an array by 90 degrees clockwise. So I've given you an example here of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, blah, blah, blah. And you can see here that the array has been rotated 90 degrees clockwise. So I want you to be able to do that and write that in a function.
Okay. So I remember like rotating arrays, we have to do. I remember the term I believe is transposing. But I kind of forgot like what exactly it means. Is it okay to ask like what transposing means again?
I mean, transpose just means that you are rotating an array or numbers. So don't
Okay.
worry about that. Worry more about like how you're gonna actually solve the problem.
Okay. Okay. So looking at this so we are rotating 90 degrees clockwise. Okay. So and it's going to be a square matrix. Okay. So looking at the problem, I'm seeing that the first row basically first it got reversed to 4, 3, 2, 1, and then we move it to basically the right side, which is what we got. 2, 3, 4. Is that the case actually? Did we reverse? I'm just gonna take a look. We did that. Reversing. So let's see. Position of 1 went from 0, 0 to 0, 1, 2, 3, 0. Yeah. And 4. 3, 3. I'm just trying to record the coordinates of them after before, just to see if there's any patterns. 3 went from 3, 0. Oh, wait, that's actually sorry about that. Coordinates 3 and 3, 3. I'm just gonna route the entire row, just because we probably are going to be dealing. My intuition is that we'll be doing row by row, so I'm just gonna write out the entire row and see how it ended up after the rotation.
Sure.
So this one is gonna be 0, 1, and it went to 3, 1, 3, yeah, and 3 went from.
Okay. Yeah, you're just testing out the idea and trying to make sure that you understand the problem. Sure.
Okay. Okay. So 0, 1, 2. Okay. So it seems like they do maintain like the relative ordering based on like what I'm seeing here. Like the x coordinates kind of translate directly to the y coordinates after the rotation.
Okay.
And let's see. For the 13, it went from basically 3, 0 to 0, 0. Okay. Rotation. Mm, and we're doing this. Are we doing? Is it okay to? Hmm. Does it matter if we do this in place or have a new array?
Um, Ideally, I'd like you to do it in place, but if
Okay.
you need to do it out like on another array, then
Yeah. Okay. Yeah.
okay, yeah.
But yeah, I was just trying to say like a brute force solution is definitely like if we could do this like with a new array, we could just iterate through the first array by rows, and then we could populate the second array starting from the top right, and we just go down until we hit the bottom. Then we start with the left column all the way, and we would start basically from the right side and move it all the way to the right side, to the left side. Sorry.
Okay.
That's how we would do it if we can do it with a new array. But if we have to do this in place, then it's most probably going to involve like some kind of swapping as we go. And I'm trying to see like what is the general pattern for each row and column as we rotate this array. Let's see. Okay. If we reverse the first row, then we get 4, 3, 2, 1. And let's see, if we do reverse it, what would this look like? It would end up being something like this. Okay. Okay, so remove that. No, it doesn't seem to map like that if I were to reverse it. Let's see. Okay. If I were to move it 90 degrees, I'm trying to think like what moving 90 degrees means for a specific element.
Okay.
If we're moving it 90 degrees, we are switching anything. So goes. Okay. One thing I do notice is that if I switch the 1 and 16, and then I switch 12 and 2, 3 and 2, sorry, 3 and 8.
Wait, are you sure 3 and 8 switch?
So let's see how like. Actually, let me put this out to make it easier to understand what I'm thinking. So I have 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I was thinking like if I switch 1 and 16, and then subsequently I have 2 and 12. So 12, 2, here I have 3, 8.
That doesn't quite work.
Okay.
So you're not switching per se. Look at where the 1 goes. Look at where the 4 goes. And then look where the 16 goes.
Okay, so the 1 goes all the way to the right. 16 goes all the way to the left. Let's see. One goes all the way to the right. So it's switching with 13. No, wait, 13. Okay. So all the elements, yeah, definitely moving to the right side. Oh, that doesn't. No, 16 is moving. Sorry, I'm still having a hard time.
Okay.
And then
what are you having a hard time with? Let's start there.
I'm having a hard time identifying what's the pattern when they do rotate in the sense of coordinates.
Okay. So so take one element at
Yeah.
a time. Don't do everything in your head. Remember, write it out.
Okay.
Just follow one of the rotations. Keep it simple.
Okay. If I'm just following element 1, then we're going from like I said, from 0 to 3 0.
Okay. Okay, so you found a place for element 1.
Yep.
Now
And okay.
now what's the follow-up?
Find out if there's a way to my first thought was like writing out like different examples earlier, like I did,
Okay.
but even after I did write out like like row 1, like 0 1 1 2 3 4, and I was not like, I saw like some pattern, but I wasn't able to kind of identify like what's needed to be done there to get to the destination coordinates.
Keep in mind so right now let me take a pause on the timer. Right now you're saying, hey, I can't solve it immediately, and then you just give up. No, follow through. Like immediately, once you found out the place for 1, the follow-up should be, where does 4 go? Because as you did before, you didn't swap the positions of 1 and 4, right?
Yep, I did not.
So shouldn't the follow-up naturally be, where does 4 go?
Okay.
I'm putting a pause on the timer because I'm trying to figure this out. Like, why is this not like clicking with you? Because you said you can't find the pattern. Well, okay, what if there's no pattern to be had here?
Makes sense.
No. I want to figure out what the mental block is. Like, what did you? Why? And I asked you what the follow-up was, and you kind of just like shrugged your shoulders. Well, I'm asking you like, what was going on through your head?
I guess like I got pretty stuck like when you asked me like what the follow-up is, and after like saying, you know, one would move to the position of 4, I just kind of blanked out over there. And I was still trying to think in the sense of like rows instead of like a single element, and at that point I just kind of blanked out, and so it kind of resulted in that pause.
Okay, I'm going to say that we need to deal with that later, but keep going.
Okay.
All right, I'll make a note of that.
Okay. So we move after the rotation. We move element 1 to the element position of element 4 before the rotation, and so 4. Let's see. I'm just gonna go through like the entire cycle and see how they move with relation to each other. 4 moves to the position of 16, and then 16 moves to the position of 13, and 13 moves to the position of 1. So they all let's see.
Wait. 1 moves to position of 4, 4 moves to position of 16, 16 moves to position of 13. Okay.
Yeah, and then 13 move back to 1, and so they all kind of replace like each other's coordinates. And and I'm seeing that, so 1, 4, 16, 13, those switch, and I see the same thing in 2, 8, 15, 9. They do the same thing, except they do swap with each other, but obviously not the same way that 1, 4, 16, and 13 do. And 3, 8, 15, 3, 12, 14, and 5 are doing the same thing. So I do see that they all switch with each other, with elements in the same order switch with each other, and by the same order I mean starting from, so we see that 1, 2, so in this case like 1, 2, 3 would be one group, 4, 8, 12 would be another group. 16, 15, 14 is another group, and then 13, 9, 5. And they are basically like swapping with another group's element that has the same position, if that
Okay.
makes sense.
Sure.
Now, when we go to the smaller one, the smaller square in the middle, we have 6, 7, 10, 11. Okay, they also swap. Right now, each group only has one element, and they basically just swap with the next group's element. So 6, 1, 2, 7, and then 7, 1, 2, 11, stuff like that. So if we work our way from the outside to inside, we basically need to get each group's elements and then swap it with the next group's elements in terms of position. If we work from our way outside towards the middle, if that makes sense.
Okay.
Let's see. So 1, 2, 3, 4, 12. Yeah, I guess like it's like this is what I mean. I get stuck a lot with like with 2D arrays. I'll get to like some point. I'll have some clues and I get stuck, and then it'll take me like a long time to kind of figure out like where to go
Okay,
next.
let's put a pause here. Let's look at everything you've talked about so far. You've talked about rotating. You've talked about like swapping in positions, right?
Yep.
What are you not doing right now that I told you to do very explicitly last time?
Am I not walking through the example enough?
No, well, you did. That's half of it. How about writing it out? Look at what you've written on the paper. Look at what you've written on the paper, right?
Yeah.
You've only shown me 1, 4, 16, 13. And even then, you've only written the coordinates for those. And then you start talking about like 2, 8, 14, or 5. But you haven't even written the coordinates for those either. And then you're progressing inwards. Like, again, you haven't written anything out. So you're doing things in your head.
Yeah, but I was talking through when I was going through it though, and I was worried like if I were to write out like all the coordinates for all the changes I was talking about, it would take too long.
Well, I mean, for the past 5 minutes, you haven't done anything, so I mean, yeah, don't you think this is a kind of a waste of a time?
True.
Like, don't worry about the freaking time. Worry about getting the right answer, then worry about the time. Like, let me ask you: is it better to get the wrong answer quickly or the right answer slowly?
I'll speed the latter.
Yeah. So what the? But like, why are you like taking away all these structures that allow you to get the right answer? Like, I mean, yeah, I get it if it's like something that's super obvious and doesn't need to be written down, but you are on a path where it's not obvious. So I'm confused. I'm the one confused here. Like what exactly is like the problem here? Like, why aren't you writing it out? I know I told you to do it last time.
Okay. Is it okay if I do it now? Or...
Yeah, go do it now. I want you to do it now.
Okay.
And see if that helps.
All right, I'm just gonna complete what I have here. So this is gonna go to 3, 3, and 16 started from 3, 3, went all the way to 0, 3, and this one from 3, 0, 0.
Okay, how long do you think
that took you? I'm also gonna write down. Sorry, what was it?
How long do you think that took you?
Like 8 seconds.
Yeah, like 30 seconds, really. Like, but yeah, like, so what do you complain about? 8 seconds. You have 30 minutes for an interview. What do you complain about 8 seconds for?
All right. And I just wanted to kind of illustrate more about what I talked earlier when I mentioned about swapping each group's element with another group's element in the same position. So in the wider circle, like the wider the wider how can I say this, the wider angle, or like if you get what I mean, we currently have like 1, 2, 3 in the first group,
Sure.
and then we have 4, 8, 12 in the second group,
Mm-hmm.
and then we have sorry, it's gonna go 4, 12, okay, 16, 15, 14,
Mm-hmm.
and then we have 13, 9, 5. So this is kind of like a spiral. Like the way I got this was through a spiral traversal.
Okay.
So I got 1, 2, 3, 4, 5, and then yeah. So I have these 3 groups, and assume that these all have like relative position. So 0, 1, 2, 0, 1, 2,
Yeah.
similar 0, 1, 2.
Okay.
And
I
what
get
I'm
that.
seeing is that I'm switching the positions of the current group's element with the next group's element in the same order. So 1 would switch to 4, 4 goes to 16, 16 goes to 13, 13 goes back to 1.
Mm-hmm.
And then similarly, the same applies for 2, goes to 8, 15, 9, and then 3 goes to you get what I mean, right?
Yeah.
Over here.
I know what you mean.
Okay. And similarly, like for the inside matrix, we only have 4 elements. So, but we also have the same 4 groups. But this time, like because they only have each group only has 1 element, and all of their elements is position 0. We basically just swap the current one with the one in the next one.
Sure. But the thing is that I'm not getting like this matrix might not be just 4x4 or 2x2. It could be 3x3, 4x4, 5x5, n by n. Your algorithm needs to work for all those situations.
Okay.
So-
Now let's see if we have a 3x3, and we could see like how in what way does it behave different. But if like, and also kind of see like what would be the common thing that we see between this 4x4 array rotation and 3x3 array rotation.
Okay.
That makes sense. So after rotating this, I know I'll have 1 over here. Okay, let's have 7, and then 4, 1. Let's see what goes here. I believe 8, 9, 6, 3, 5 doesn't move. Okay, 2. So let's see. Okay, so I still see that the first row will be in the last column. That's one thing I noticed. First row goes to last column. So we could say n-1 column. Second row, let's see where it goes. Second row, 4, 5, 6, basically turn into the n-2 column. And then last row, the nth. Last row went to S3 column. Okay, this is what I currently see. Let's see if I were to switch. So I'm thinking of like, if I were to say swap the elements of the first row and the last column.
Okay.
With that, like after swapping, I want to see like what happens next. So I'm just gonna take the original one, and I'm gonna modify it. So if I were to take the first row and swap it with the last column, let's see. If I start from the top, does it make sense? I'm just gonna try it out. 2, 6, 3, 9. Okay, that's what I got after swapping the first row. But then now the order doesn't seem like what it's supposed to be. if I were to continue doing the same thing, and swap the second row with the n-2 column, 5, 5 stays the same, 2, 4, 2 goes back to where it was, and if I were to do the same thing, 7, 8, 6, 9. Okay, it didn't seem to work here.
Okay.
But
But your idea, I would say that your idea up here of like 1, 2, 3, 4, 8, 12, 16, 15, 14, 13, 9, 5 seems to work pretty well. So I'm like, why don't you try to carry that over?
Okay, if I were to carry that over, that means I would have to use 1, 2. No, this is. Okay, so if I were to use the same idea, then I'll need to have the same groups, like I mentioned before. But then because this is not a square matrix, I don't have groups with the same amount of elements in them.
Okay.
Let's see. If I were to still have the groups, but I could have duplicates in them. Let's see what it will look like. 7. Yeah, 3, 6,
Well,
9.
okay, so you have lots of duplicates, whereas this one doesn't have a lot of duplicates. So what can you do to eliminate the duplicates?
Two, 4. I could take one element off each of them. So instead of having 3, I could just have 2 in each group. So it'll be 1, 2, 3, 6, 9, 8, 7, 4. If that makes sense. So it seems that each group will have. So the amount of elements in each group will be n-1. That's what I'm seeing. Over here in the 4x4 matrix, we have 3 elements in each group, and in this 3x3 matrix, we have 2 elements in each group.
Okay.
Okay.
Yeah.
And then I'll do the same. And then I would do the same thing. So I'll swap 1. Sorry. So they all have like 0 positions would be 0 and 1. So 1 would swap with 3, and we can see that the same thing happened down here. 1 went from this position to this position. 2 swaps with 6. So it went from 2 to 6, and then 6 went to the next one. And the same thing applies for the other elements. And then when we got to the middle, because there's only one element, there's nothing to be done there. So
I want to point out that something else that you understand that, but then what are the final coordinates that you're going to land on? Because you've only done the corners here, right? And those seem pretty easy for 1, 4, 16, 13. But then what about the other elements? Like, in going back to the original example, what about 2, 8, 14, 5? What are the coordinates for those?
So say if I have like the groups, say if I have the group of elements, I could swap the elements in this group with the next group, though.
Okay.
No.
Sure.
That's what I'm thinking, but like but then it would be tricky like managing like the state of the algorithm.
Okay.
Because then once I swap the first group with the second group, the original second group that was supposed to swap with the third group, we now have to refer back to the first group because they swap with the original first group. So that's gonna be messy managing the state.
So what is the very simple way of doing it then? Like you said, managing these groups are gonna be kind of messy. What would be a very simple way of handling it?
So we definitely don't want to store actual coordinates. We need to swap them. So we have to swap them in a way that we don't have to manage or like keep track of a lot of states. So looking at the original example, I wrote down 1, 4, 16, 3. I didn't write 2, 3, and the other stuff. Let's see. I'm just gonna write 2 and 3 as well, just to. I know it may be a little redundant, but I'm just gonna see if that helps me.
Sure, that's fine.
So 1 goes to. 3, 1. Let's go to. And I'm gonna try to write down the next one as well. So 4, 8, 12. Okay. 8 and 12. So I'm just gonna write down these as well. So it's 1, 2. 12, 8, 12. Okay, and if I were to separate them, just like the groups I wrote out, it's gonna be 1, 2, 3, 4, 8, 12.
Okay.
So let's see. So 1, 2. Yeah, I guess I'm still not able to identify like what you meant by like when you asked like what's an easy way to do this. If I were not to save states, I need to find
Okay.
out the pattern to.
Okay. Note. Okay. So
Yeah.
the fact that you had to move it chunk by chunk, and remember with the previous thing,
Yeah.
and like, oh, I need to remember to shift the coordinates here, means that you're going from this group to this group, right? But that's only
Yeah.
because you're moving things in terms of a group like this. What is another way that you can simultaneously move things?
By swapping one element with another element.
How about a four-way swap?
Oh, okay. I see what you mean.
Yeah, like just because you can swap 2 numbers, you can swap 4 numbers, right?
Yep.
Okay.
Yeah.
Go ahead.
Okay. So if we could swap them, if we could swap all 4 elements together, then essentially once we have all the groups ready, then we can swap all 4 elements in each group as many times as elements they have in each group. If that makes sense. So in this case, like each group has 3 elements, so we will basically do 3 swap operations, with each swap operation swapping 4 elements altogether. And in the second example, where we have a 3 by 3, we will do the same thing, but we only have to do 2 swapping operations.
Okay.
Now, so yeah, so I guess in summary, like I would work my way from the outside towards inside, and each time I would just get all the available groups and then swap 4 elements until I'm done swapping it. Then I'll move 1 block towards the middle. Now, I'm trying to see like how I'm trying to think like because then I'm trying to think like how I would actually do that in terms of code and like how I would like traverse in towards inside the array.
Mm-hmm. Well,
because this approach of like getting groups and then I can be able to swap elements and it makes sense on like in words.
uh-huh.
But translating that into code is what I'm
Okay.
kind of worrying right now.
Okay. So then suppose
Yeah.
that element 0. Okay, so then trying to translate it into code. Okay, well, can you come up with a general way of representing this rotation then?
A general way of representing this rotation.
Mm-hmm. So let's say you iterated through it, right? You have elements as element 0, element 1, element 2, right?
Yeah.
And you see that it gets moved over to 0, 3, 3, 0, 3, 3, 3, 3, 3, 0, right? So then, in general, how could you express this relationship for the swaps?
In general, how can I represent this relationship in terms of swaps?
Like if I have I and X, or I and N, right? I is the element I'm at, N is the size of the array. How do I do this?
Sorry, say I was what again?
So let's say I is at my index. I equals index.
Yeah.
N equals size of the array. Can I come up with a relationship for the four-way swap?
Okay. So using that one, so we have 0, 0, 3, 0, 3, 3, and 0, 3. Relationship for the four-way swap. As in a way to compute its destination index, or
Okay.
like, I guess I'm still wasn't quite sure like what you mean by relationship for the four-way swap.
Okay, so let's say I have a size n by n matrix, right?
Yeah.
What coordinates would these land at? You know what? Actually, I'm gonna pull the plug here because I'm gonna pull the plug here because I have a few things I want to talk to you about. So So what do you think? What do you think went right? What do you think went wrong?
I think what went right was that I tried to write down some of the changes in terms of coordinates. Especially like after you told me about the not worrying about like the time management and worrying about like the solution. So I think like writing more down definitely helped me. Even though I didn't get the actual like solution, I think like I was just able to make a little more progress and not get stuck in the same spot forever. I think what went wrong is just like I wasn't quite able to generalize like what I had. And yeah, and like just like I think I just wasn't able to generalize like what I had and come up with like a relationship like you said for the swapping operation. Yeah.
Okay. So basically, what I saw was that you gave up because, I don't see the pattern. I don't get it. Therefore, it must not exist. I give up. That's basically the crux of the issue. You just give up because you don't see it. Is that pretty accurate to say?
Yeah, it is.
Yeah. And do
Yeah,
you
I
do
feel
this
like
on every
that.
single other problem as well?
Sorry, what was it?
Do you do this on all your other problems as well?
This is fairly common when I practice as well. Like because I do rely on pattern. I feel like I do have like a pretty huge dependency on patterns, and then once I'm not able to identify a pattern, I usually get stuck pretty long, and I'll try to like kind of scratch it and just like start fresh and see if I could um, find out or like yeah, basically like find a way through the solution.
Okay.
But
So,
yeah, this happens frequent enough.
did this happen very frequently last week?
Um, like when I was doing practice
Yeah.
questions in API,
Mm-hmm.
I wouldn't say so. I guess this for strings and those. No, I wouldn't say it happened a lot, but it does happen when I do practice leak code questions,
Okay.
especially with questions that are not as common
Mm-hmm.
or like questions that may be a little tricky in terms of the description. This does happen.
Okay. Yeah, I know what the
Yeah.
problem is now. Okay, so there's another. So you probably read only one part of the guide. Like, oh yeah, study pattern, and you're good, right? But the thing is that my guide, there's like other parts of it as well, like like being able to derive and break down problems. And so I would highly recommend you read that part. But let me
Okay.
copy paste my notes here. But
Okay.
the thing is that yeah, you blank out because you give up, and you give up look at the answer. So this is basically all your bad habits of like, oh, I don't know, therefore I'm going to look at the answer, and that's it. That's basically all those habits that you've been doing coming back to bite you at the same time. It's like, I don't get it. Therefore it doesn't exist. Therefore I'm going to look at the answer. But then the question is, what steps do you take after looking at the answer to ensure that you'll get the answer the next time? And I can only guess that you memorize the answer and that you don't actually try to figure out how to derive it. Is that fair to say?
Uh, I guess another thing I do as well is I try to see like what type of characteristics like this problem has, in terms, like, and then like so if I see another problem that has like somewhat like of the same characteristics, I might be able to consider like the solution for this problem. But for the other parts, yeah, you're right.
Okay. Yeah. So I mean, quote unquote characteristics, but to me, you don't actually take the steps to improve your problem solving. So let's actually go through this problem and let's go through like your logic and see if we can come up with
Okay.
figure out how to derive a solution. So
Okay.
first things first. So it's like you wrote it out fine. You try to figure out like, oh yeah, well I need to group things up. So this is me acting as you.
Okay.
I need to group things up, because then it's easier for me to handle. Correct?
Yeah.
And then one thing I didn't like is that, well, what are the next logical question to me would be like, okay, well, you group them up. It's like, what are the coordinates? Like, what are the coordinates that they go to? How do you manage the groups and etc. So that's the immediate thing. Like, just because of the consequence of like what you said and what you did, you group them up. Well, then how do you manage those groups? That is a immediate and direct consequence of you grouping them up. It's direct. Once you group them up, you have to manage it. That's inescapable. I don't see any way out of it. So to me, it's like, okay, great. You understand like how these elements are shifted, but then what if it's a general n by n matrix? How does that expand out? And so that's why I tried telling you, hey, well, maybe try reusing this idea on a smaller matrix or another matrix, because I think as you saw here, you eventually got to the idea of like, oh yeah, well, all I need to do is iterate until a particular element is found, right? So to me, the next question would be like, okay, I see 3 by 3. Let me confirm with a 5 by 5, right? This is the way I would have done the problem, because like, okay, I see that this idea kind of works. Let me see what happens in a 5 by 5 matrix. So then let's say that 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23.
Wait.
Yeah, I fucking miscounted. God damn it. 16, 17, 19, 20. 21, 22, 23, 24, 25. So this is basically what I would be testing it on, right? And then afterwards, I'll be like trying, oh yeah, well, I would be grouping things up like 1, 2, 3, and 4 gets grouped together, right? And then 5,
Yep.
5, 10, 15,
10,
20 gets grouped up together, etc., etc., and then like 25, 24, 23, 22 gets grouped up together, and then 21, 16, 11, and 6 get grouped up together. It's like, oh, okay, well, now all I need to do is look at until the n-1 element, or the, yeah, n-1 element. You see like how we're slowly starting to build it up?
Yeah, I see this.
And all I'm doing, the only thing I've done here is just try different like element sizes, see if I noticed anything.
I actually did notice the n-1 element group size, but I guess I just didn't really mention that. But I did mention, I think I did briefly mention it when I said like the size of the groups is n-1. But then I guess like from that point on, I wasn't sure like how exactly I would like get the groups, and then I got stuck there.
Okay, so to me it would look, to me it's like, okay, so let's say you got to that point, right? And so me it's like, okay, let's start with your train. Okay, I need to group up like this first batch of elements from let's say I iterated through this chunk here, right?
Yeah.
This is row 0. And then I go through between 0 to n-1, right? So
Okay.
I'll pick up those first elements, right? And then I need column, and the group here formed will be column starting from row, yeah, so column from where 0 to n-1, column n. Because this is where the column exists, right? And,
yeah.
And then I would descend down that column, keeping the, descend down that column. So the column is static. So, and then row, this is like row is static. Column n, and then the next one would be row, row n. Well, I should say, if we're doing this by index, it should be n-2 here, really. If we're doing it by index. So let's make that adjustment here. So then row n-1, reverse traverse the row. I goes from n-2 to, I would say n to 1.
Oh, 0, 1, yeah.
Yeah, and then back, and then go up. So then column 0, I goes to, n-1 to 1. Something like this, right?
Yeah.
Anyway, so like now that I've done this, I'm gonna be looking at this like, holy shit, this is like, yeah, how do I remember which row is what, which column is what? I mean, I could break this up, and then just be like, I like the very naive way of handling this would be like, okay, let me do all these operations, and then move them into like say element. Let's say a chunk A, and then chunk B, chunk C, chunk D, right? And then move chunk A to chunk B to chunk C to chunk D, or some shit like that.
Yeah.
That would work. Right? You would agree, right? But it's not elegant. Yeah. But at least I have something that works. That's kind of the point. You should have immediately thought, okay, well, at least I have something that's not elegant, but I know how the traversal works. You should have at least gotten to this point. And I think you shut down because you didn't see, oh, it's an easy, elegant solution, therefore it must not exist. That's where your mind kind of shut down.
Yeah, you're right.
Okay. But yeah, at least we have something, but something in it works, but it's not very nice. So, and it's very, very unwieldy. So, obviously, we don't want to go there, but at least we can acknowledge that this exists. So then we start asking ourselves, what is the inefficiency? The inefficiency is that we're managing a bunch of groups, which we've kind of done here, which we acknowledged here. We just didn't know how difficult it would be to coordinate it, but now we see, oh shit, it's super fucking hard to coordinate all these. Now, if you made me write an algorithm for this, I could do it. I just would say the code is going to look like shit. So which means that, okay, well, this whole reason we need to coordinate groups just falls out because we have grouped things up. So then the next question is, well, in order for me to avoid this, like, how do I solve this problem? without grouping up the elements. And this is what I tried steering you towards a little bit. And I said, hey, what if you just did a 4-way swap? And you were hung up on 2-way swap. So I'm like saying, okay, well, what if you did a 4-way swap? You know? And after that, that should be easy cakes. Because now all you have to do is like come up with a general algorithm for all this shit. So, in other words, this would mean this would imply you need to complete this. But, you know what the nice thing is? We kind of already did that here. We kind of already did some of the work up here because we actually tried it. So, in other words, if we wanted to come up with a relationship for the 4-way swap, then I would say, okay, well, for the first, is that I would swap all the elements around the array. Like, let's say I'm at 1, 2, 3, 4. Let's take 1, 2, 3, 4. The example I gave you, right?
Yeah.
So I would say, so the first round, I would just swap the outer shell, swap the outer shell. Then next round is like, look at the inner shell after. So the only elements, I don't care about these elements, I don't care about this element, I don't care about this element, I don't care about this element. All I care about is rotating the outer element shells and then treating the n by n matrix inside it afterwards. So then that means that, okay, well, I really need to come up with this 4x4, this way of swapping 4 elements and coordinating them. So I can see that based on the way I've written things, that I need to swap 1, 4, 16, and 13, right? So which means that the row of, let's say 0, 0 goes to 3, 0, goes to 3, 3, and then goes to 0, 3, and then goes to 0, 0. Now, if I know what I'm doing here, then to me this looks like, okay, well, we just take the element at 0, and then we swap it for n-1, right? The element at n-1. At least this is what it's looking like to me. It's 1, n-1, and then 0, blah, 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 you get the idea. Okay, so then the next trouble will come in like, okay, well, now that I have that, what happens if I try swapping 2, 8, let's say 2, 8, 14, and 5, right? So then what are the coordinates that are at 2, 8, 14, and 5? Well, you identified that 2 is going to swap with this, and then after that, you have 8 that's going to swap to here, and then what's it called? 14, it goes swaps from 2, 3, all the way to, what's it called? 1, 2, 3, 1, 3, and then 5, and they get swapped with, I believe that you said it was, no, 2, 8, 15 gets swapped, and then 9 gets swapped.
9, yeah.
Yeah. So then let's say, so 15 is actually at coordinate 1, 2, 3, 3, comma, what is it, 1, 0. Oh, you use X and Y, so then this would just be 4, 3, right? Yeah, 1, 2, 3, 4, and then 1, 2, 3 over, and then that gets moved over to where 9 is, so that would be 0, 3, 0. I think based on what you've, oh no, 0, 3. Because you're moving X and Y coordinates. So you're 1, okay, so then you use this as your, actually you use this as your Y coordinate, okay. You actually wrote it like this, by the way.
Did I? I thought I did.
Yeah, I'm copy pasting what you did here.
If 2 is, no wait, like.
Where's the 2 here? Where's 2 here?
Two is at column 1, oh, like index 1.
Yeah, so I've read 0, 1 for me. Yeah, so you made a little mistake there. You made a little mistake there.
Okay.
Okay, so then 15. So then 15 will just be at 1, 2, 3, 4, 0, 1, 2, 3, 3, and then 0, 1, 2. So okay, so it goes to 3, 2, 3. Yeah, and then you swapped it here too. So you kind of need to get better at the 2D array thing. And then goes to 3, 1, 2 goes to 1, 3. So you need to be much better at this. So 1, 3. Yeah, you swap Y next. So then 9 is going to go from 0, 3 to then 0 to 0, 1.
Yeah, I messed up a lot when it
Yeah, you
comes
messed
to
up. Yeah. So it
to
gets
the
it's a
array
little bit coming.
coordinates.
Yeah. All right. Either way, if you do x and y and x, it doesn't matter. You get the point here. And so you
Yeah.
try to come up with a relationship for this. Oh wait, no, this is yes. Okay, so then x. Oh, do you do x comma y? Wait, maybe I fucked up here. Let's say wait 0. No 0 comma 1. Yeah. So I do yx. All right, whatever. Point is that y is gonna be 3 comma 0 comma 1. Okay, the point is that you're gonna keep doing this, and then eventually you will come up with some relationship here, and what you're gonna find is that oh well, instead of n minus 1, it's gonna be n minus 1 minus I or something. You get my point?
Yeah, I get your point.
Okay. And so because of this, you're gonna eventually like what I'm trying to really show you here is that it's going. You just need to keep progressing through it, and the logical next step is like, oh yeah, well this is kind of like this is where I need to go to, right?
Yep.
Okay. And so basically, you just keep doing this, and then eventually you find some mathematical relationship after you try every single example. But the point here is really try every single example you can. Try the examples, get to everything you can get to. And you see like how one of our observations fed into the next observation, right? And we're able to keep making progress. And whereas what you're doing is you're looking for a magic bullet. So what I'm going to tell you, the first thing to take away is no magic bullets. So this is why you blank.
Okay.
So figure out what you need to do to get a naive solution. Follow the thought, and then retry if you find that the naive solution sucks. So I want you to do this idea of following through. It's like, okay, you got the ideas out. Now let's follow through on it. That's the next step.
Okay.
Okay. And this will help you with your array problem, because now that you understand that, then you'll be able to just keep going forward for it. So, yeah. So I think I wrote down run through the full idea. So which means that he's pushing that idea as well. So, okay. So with that, this kind of follows up on try the idea afterwards, or I should say try the idea fully before code. So yeah, we're getting to the parts where like, oh well, the pattern doesn't actually exist. So I need to give you more problems where the pattern doesn't actually exist for you. So, but hopefully you start to see what you're doing wrong here.
Yeah, I do notice it. I mean, I do know it.
Yeah, and then eventually you'll get to a point where it's like, okay, well, I know that it's going to be some coordinates of like I and then comma n minus 1 minus I, or then swapped with the coordinate at n minus 1 plus I or some shit like this, comma I, etc., etc. And you basically come up with this mathematical relationship for the swaps as you keep trying the examples and just like saying, hey, does this actually work? Let me try it. That's all you have to do. Just fucking try. Does it make sense?
Yeah. I guess like just following through. Sometimes I just like you mentioned, like when I realized it wasn't like quite an elegant solution, I didn't follow it through fully.
Yeah, and that's basically the problem I see right here. Yeah. So is there any other questions before we go to the next thing?
No, I think this was pretty clear.
Okay. And so I'm gonna assign this as homework. Actually solve this problem for homework. And I want you to do a write-up for this.
Okay.
And what I mean by write-up, I mean like, okay, write down the solution, what steps you took to get there, what you could have improved on where you got stuck, etc. So I want you to be able to do this, and I'll check it on Thursday.
Okay.
Alright, so let me see if I can find you another array problem. Give me a sec. But you did say you had some struggle. You were struggling a little bit with recursion, right? Or are you good on that?
No, I do struggle a little bit on it, depending on the type of problem.
Okay, did I give you the IP address problem?
No, you didn't.
Okay, so I'm gonna give you that one to you. I'm not gonna time it, but I really want you to practice this idea of pushing forward with your solution if it doesn't make sense. But I think this one should be a good exercise in that. It's a little bit easier. So I want you to compute a valid IP address. So suppose I have a what's called some string where everything is garbled,
Yeah.
right? Where we lost all the subnet decimals. So in other words, this IP address, this string here, could represent these 4 different IP addresses. And so what I want you to do is, given a particular like a string of digits, I want you to return to me all the possible IP addresses that it could represent. Does this make sense?
So given a string without any periods, we want to compute all the possible valid IP address. Is that right?
Yep.
Okay. So let's see. And we're doing this only. Okay. So one thing I do remember is that IPv4 addresses have 4 pods, and each pod, in order to be valid, it has to be a value. Of greater or equal to 0, and then less or equal to 255. Okay, and the other thing we know is that so the length of each pod is going to be between 1, 2, 3. Okay, so let's start with what we have here. So basically, we're just going to be computing all possible. Okay, so I mean, obviously we have the brute force way of just basically computing all possible combinations of what do I say? Combinations of IP addresses using 3 periods, and then we validated them. Now that wouldn't be quite efficient because we know like what I wrote down here, length of each pod is going to be between 1 and 3. With that, we already eliminate. I would say we eliminate a lot of these redundant combinations that we end up computing if we were to go the brute force approach. Let's see. So I don't see an easy way out with this. So it seems like we would have to kind of start from the beginning and place periods. How do I say this? So we have to place 3 periods for sure. But we definitely do need to try a good amount of combinations. Okay, so what I'm thinking, so what I have in mind is like, so say we have something like this, and we do place the period after the first number. We then would need to place 2 periods in the rest of the string.
Okay.
And obviously, if we place it here, this wouldn't work because then the remaining length is too long. So if we move 1, this doesn't work as well. Continue this. This may work. Okay, yeah. Then we would kind of do this, and we realize that this is too long. Then we come back and we do this. Actually, wait, sorry, my bad. We wouldn't even place it here because then it would be too great. And then we go, yeah, do that. Okay, so we definitely do need to try different combinations. I'm trying to see like what will be the conditions or ways for us to try these like to generate these different combinations for IP addresses. 190. Let's see. If we have 4 sections, and we have to do this by each section, we will kind of need to have, like, I guess, nested loops if we want to go part by part. With 4 parts, let's see. Um, okay, I know I need to get the groups, but I'm I'm still thinking of like how exactly I would do the actual creation of the current combination.
Okay, so let's look at what you've written down. So you said compute all possible combinations of IP addresses using 3 periods, and we validate them all. Right. So if we like put put them in like fucking random places, and then we just like check to make sure that they're all good, then technically this does make this is a valid answer. But like you said, it's also incredibly naive and crazy, and there's a lot of waste.
Yeah.
So the next question is, well, how do we clean that up? Why is this inefficient?
So, like I mentioned earlier, as we're placing periods, so if we're processing from the left to right and we have 3 periods placed, we should only, so we can only place the period if that section doesn't creates a number that falls within the valid range.
Okay.
So 19, like 1 would be valid, 19 would be valid, 190 would be valid, but obviously like this would not be valid. But not even just length. So say even like, so this like three characters are valid in terms of length, but 812 is definitely not valid in terms of value. So as we're placing periods, like we kind of need to keep track of like what is the current value of that combination if we were to place a period here. And if we do place a period here, assuming that the combination, I mean that section, so say like 190 and I place it here, this is valid, I would then need to process the rest of the string and kind of add like the remaining amounts of periods that I have.
Okay.
So let's see. 1 plus that. Okay. And the other thing I do know is that the input has to be at least like a 4 up to 4.
Okay. So yeah, like I would definitely say like now that you've got this idea, I would try writing down the pseudocode for it. I think you have something going. Try to drive it a little bit more.
Okay. So I have okay, input string, and we want to okay, so we have 3 periods allowed. We would move to the right and build up first section. If valid, we kind of process the remaining string. And we will kind of repeat this 3 times, if that makes sense. So we'll do, let's see if 3 times. So 19168. Yeah. So we kind of do this 3 times. So in the example of like 190.168.122, say 1 is valid, we kind of repeat this 3 times. So 9 is valid, 0 is valid. But then once we hit here, we know that this is not valid. We put it at the next place. This doesn't work. Next place, this doesn't work as well. Okay, I guess I can see that if we don't even need to continue trying this. If the remaining length is, if at the current section, at the current start index to the end of it, if it's greater than 3, then we don't even need to try it. Then we just move forward. Instead of starting here, we go all the way back. We do increment it by 1. This is 6. Okay, I guess we could go like that. How would I do this? Okay, so let's see. I have to place period at every step. Let's see. Let's see. Let's see. So 190. Okay. If it's valid, then I continue. Okay. Let me. So build up this part. So basically be from, say in this case we're giving from index 0 to 3, and then for each time we want to continue on the rest if current section is valid. If that makes sense.
Yep. Okay, build up the first part with index 0 to 3, sure.
Okay, so one thing we have to keep in mind is like when we go to the next part, part 1. Okay, so say we build up first part. Okay, then we build up second part. If valid, we build up this third and fourth. Let's see, if second part is valid, third and fourth.
Okay. So you're basically proposing 3 nested loops, right?
Yeah.
Okay.
Okay, and then once we get to the last part, I guess we don't need to have another nested loop, but like once we hit this section here, because we can only place 1 period at this point. I think this should be the last nested loop we need to go. Initially, I was thinking I need to have another one.
Okay.
But since we're only placing 1 more, this could be the end of the amount of nested loops.
Sure. These are all the nested loops. Fine. But what I'm gonna say is, okay, well, it's gonna look a little bit ugly, right?
Yeah.
Okay. So then, how do we make it a little bit better?
If we have a helper function, or like a generic function that we could call with certain parameters in order to do this.
Yeah, but the ugliness doesn't come from like a helper function. The ugliness comes from having 3 loops. So how can you eliminate those 3 loops?
How can I eliminate So you're saying the ugliness is not from like me doing recursion like again and again? But
no. Okay, you're actually gonna do this recursively. Because I literally asked you if this was gonna be 3 nested loops, and you said yeah.
Yeah.
So where does recursion come in?
Oh, okay. So I see what you mean. Oh, okay. So yeah, so that's what I meant by having a helper function. And I was confused when you said like it will look ugly. So if I were to have a helper function, then that function would do the recursion. Does that make sense?
No, it doesn't. How? What are you trying to do with three loops and recursion? Let me ask that.
So no, if I were to do three loops, then I wouldn't be using a helper function.
Okay.
But you're saying three loops are ugly.
Mm-hmm.
So I so three loops would be no helper function.
Okay.
We just compute like that, and then at this point, if I were to go through loops, we reach this final point. We just say if valid, then we know like because we know like the previous parts were valid. If valid, we can just append
Sure.
to result.
Okay. Fine.
Now, if we have a helper function, we can potentially pass in indexes and the entire string to valid to kind of do recursion in order to build up uh, the final result.
Okay. Fair. So go ahead.
Okay, so if we were to do so let's start out simple. If we have a string as we know we need to try combinations. Let's see, how do I define the conditions? So let's see, if we have a helper function, taking the string, taking current index, and it's like periods left. Current index, okay. We would, let's see. So I definitely know I need to, I'm able to kind of do this with a helper recursion function, but I'm trying to think like
Just do what you need to
are the
do, and then I'll talk
Okay.
about it. But I think I know where you're going with this. I want to see if you can follow through on it.
Okay. So that's what I'm trying to identify because I know like with this helper function I can do the recursion, but I'll need a certain set of conditions to help me identify like how exactly I would do this. So let's see. Beginning, you would call helper function the string index 0, periods left would be 3. Now in helper function, we want to see what try first 3. Actually, let's see 3, but the length of the string could be 4. I'm just gonna start with a naive example. So assume that the string is always going to be length of 12, meaning it would be.
Okay, well, the thing is that you're assuming that the length of the string already, so shouldn't that be something you clear up? Because I'm going to tell you that the string could be, it could be short, it could be too short. It could be like fucking 10 characters or whatever.
Yeah. I'm just saying, like, I'm just trying to see if I could define it as 12 now and see if that would help me kind of write up how I would do recursion on this.
Sure.
And then after that, we can kind of see like way to modify this to kind of accommodate the different length of it. So if we're so if the example is always going to be 12, then we could obviously try first we always have to take 3 characters and then call helper function and rest. Let's see. No, it's not. So I think it's gonna be at least 4, because 4 is gonna be the minimum length we need in order to compute a valid address. And assuming the input is valid, we have at least 4 all the way to 12. Okay, I guess the first section is gonna be at least 1 character all the way to 3 characters. Let's see, what does this? I'm trying to see like how this translates in terms of like the varying length we could get. This would be, what would it be? Range 1. Think of S. Okay, so in range of 1 to, I guess, minimum, is that right?
Okay.
Range of 1 to minimum, that makes sense. Let's see.
Sure.
I guess second section, range of, what would that be? If we have 1, 4, think of S.
Okay, I'll let you finish the startup, but I want to point out something afterwards. But go ahead, finish up.
Second section would be 1 as well, 2. I guess they would be the same, but the S here would be a substring.
Okay, I want you to stop here. I want you to talk to me about like what's going on in your head, and I want to point out something to you. Like what have you been doing for the past? I want you to point out what you've been doing for the past 20 minutes, and I want you to like go back over the past 20 minutes, what you've written down, what you're doing, and what you think is why you are taking a long time on this.
So, in the past 20 minutes, at first I started out with like, what are the conditions for a valid IP address?
Okay.
And then next I move on to talking about like, obviously the brute force, we can do this. And then realizing that, okay, there's a lot of redundancy and there's some ways that we could do to not go down the rabbit hole. So is that we have 3 periods, and I had the idea of like trying different combinations, and if the current section is valid, we continue on the rest of them. Okay. And then that's when I started out writing the nested loops.
Okay. But up until this point, you
Go
keep going.
Sorry, but even at this point, it's still pretty vague. Like I was saying, like I was building up sections, and if valid, I go through, and then like in the end, if it's still valid, I pen through the result. But I still, so this is the general idea, but I guess like I'm still pretty vague. I still didn't really have a clear idea in terms of details as to like how this would be implemented.
Yep.
And then when we got to the loop and we had to recursion, I guess that's when it started to kind of bite me, because then like I had the idea that I kind of have to pause like section by section, but because I didn't have a clear idea of like how this would be implemented and like what are the different conditions, when I had to use a helper function and generalize this whole nested loops thing, it kind of came back to bit me, and so I wasn't able to make progress as quick. Like I was trying to write out like to see like how this helper function would process a certain section, but I wasn't able to come up with a general enough way to do this, and that's kind of where I, kind of stayed stuck for a while. But I was like pretty sure like this is the way to go. Like if like to do this problem, like we have to do section by section. But I just wasn't able to come up with that, or like kind of find out like what's the next logical step and like how exactly I would determine like what are the conditions. Like because based on like our previous practice, I think the one thing I noticed was like you would do the current thing and then you figure out like what's the next logical thing to do. But I guess like when I got here, like especially like determining like how exactly we would pause a certain section, I wasn't able to determine like, okay, I'm at this step, but I'm not sure like how exactly like do I do this step or like the next step, if that makes sense.
No, it makes perfect sense. And you know what started all this? Do you know why you're in this position?
No, actually, no, I actually don't.
It's because you didn't even try an example. You didn't try walking through an example. Like you said, I don't have a clear idea. You went through this, right? You came up with this. You went through this, but you only did it for this naive idea, right? Where's this idea for this one? For the follow-up when you tried to optimize on it? Or where's it for this recursive call?
I mean, I did do it briefly, like when I was doing the placing periods and the nested loops. I was going through as if like we were placing them on the actual input.
Okay, but I mean, you did briefly, but it's like to me, it's like I don't see you going through it. You know, it's like you kind of mentioned. I think you mentioned it in passing, but you didn't actually try like going step by step through your algorithm, or at least try going step by step through your idea with it. That's why you have a not clear idea.
No, but I did talk about like having. So say we had this string. I did mention that we started with one, and then we would place it here, and replace it the next one, and a third, and then we would find out that this is not valid. We would go back and stuff. But then when it got to like actually writing out the helper function and stuff, I guess like.
Yeah, but that's the thing. You just talked about it. You just talked about it briefly, but you didn't actually try like going through it. You talked about it. You didn't actually try going step by step through it.
But the thing is, I feel like I didn't have like enough details to go through step by step. Like I knew I had to compute like a certain section, and then move to the next section.
So your solution was to do it in your head?
No, I wasn't doing it in my head. I was just like trying to see like what conditions. Like I was trying to build out like the details here, and then walk through the example to validate the details. If that makes sense.
To me, it sounds like you're just trying to come up with like what it looks like in your head, and instead of just like trying it out. Here, let's prove this point. Why don't you try like going through on this string how your algorithm would work step by step? Watch do that and see if it changes anything.
Okay. Okay, so we would take first three characters, number 4. Okay, so I would take the current one. We would start with 1.
Okay.
Place a period here. Now this 1 is valid, so we would continue on the rest. 9 is valid as well. We continue on the rest. We place 0. Then we know that this is not valid. We go back.
Okay.
We place it in the next one. This is also not valid. We go back. Place it in the next one. This is not valid. And so on and so forth. This doesn't work.
Okay, well, why do you need to keep going? You already stopped at 1016, right?
Yeah.
Why do you need to go 0168?
Okay.
I mean, technically you could, but my question is why?
Yeah. Okay. So, yeah. So if the moment I realize that this section is valid and this is the section that's not valid, I don't need to continue.
Okay.
I would just go back all the way back here. add
Okay.
it to this one. Now do the same thing. This is valid.
Okay.
This is not valid. Go here, same thing. Okay, now I have a valid. So I would add this to result. Now, if I move on, I guess I wouldn't move on because this is already set here, and there's nothing I can do. I would go all the way back, and 901 is not valid. I go back here all the way back to 1.
Okay.
Now I do 19.
Okay. So
Zero is
so
valid.
you're able to walk through
Yeah.
it now. Okay. Does this
Yeah.
help you? Do you have a clearer idea of what you want to write?
No, I don't. I knew this is what I had to do, but I wasn't sure what I had to write to do this. If that makes sense. I knew I had to do this, but I just wasn't clear on how I would translate this into the implementation details.
Okay, let's do plain English,
Okay.
plain fucking English, like a 5-year-old child, right?
Okay.
So describe it in 5-year-old child language. Like I'm a fucking I don't know, like fucking noob ass shit. Like describe to me what you're doing, like step by step. What are the steps you're gonna do?
Okay, so I'm just gonna if I were to simplify this.
Simplify the idea.
Okay. If I have a valid section,
What's valid section? I don't know. I'm starting off. We're starting off 0. I don't know what valid section is yet. Start simple.
Okay.
What do I do first?
I would basically build up a section. Basically, if that makes sense.
Okay, build up a section. How?
I would process the string from left to right, character by character.
Okay.
To build up a section.
Okay.
And if I have a section,
I don't know what section is because okay, now you're processing a string, but then I still don't have a section. What's my section?
Okay. So as I'm processing the string from left to right, I add the characters together and get that integer value.
You lump characters together by what? Lump what characters together?
So I would have the I guess I could either do int conversion or I could do
Don't worry about the little details like that. I'm talking about
okay.
All you've written down and told me is you're building up
Yeah.
a section, processing a string from left character to right character. Okay, I get that you're
Yeah.
going to iterate through this string, but I don't
Okay.
have a section yet. Is my section 1901681? What's my section consist of?
I see what you mean now. Okay, so a section is a string that has at least one character.
Okay.
And up to 3 characters.
Okay.
And by characters, I basically mean the number strings that we have in this input.
Okay.
And we know that this section, or a section, is only valid if its number value is between 0 and 225 inclusive.
Okay, so you're going to build up a section. You're going to say that a section can be 1, 2, or 3 characters. Okay, so let's say, all right, so let's say I start here.
Yeah.
Now what?
Then I would continue processing the rest of the string.
Okay.
Similarly, building up the sections. So we want to end up with 4 sections.
Okay.
That's something to mention for valid sections.
Okay.
In order to say this is a valid IP address.
Okay. You want 4 valid sections. Okay.
No. Now, every time we have a section computed or processed, we basically process on the remaining characters we have.
Okay.
And let's see. This is the high level, but I'm trying to see I'm still not sure like how deep I should go. And,
No, if
like,
you have a large idea, then honestly, this should be good enough to start writing code with, to be honest. But my concern is that you say you still don't understand what the idea is. That's what I'm trying to
so
figure out.
Okay. So yeah, I know I have this idea here, but I guess like, yeah, writing it out. I can try writing it out, but I'm not sure if I will be able to like, handle like the details entirely yet, if that makes sense. And I'm not
Sure.
sure like if I should continue like walking through on this.
Give it a
or
shot.
I should,
If you're saying you can't handle the details, then that's another issue altogether. But I want you to give it a shot. It seems like you have an idea. Go for it.
Okay. So we have a compute file addresses string. And we just do a simple sanity check if string is less than 4, length of string is over 12. We just return empty array. Now, we mentioned a couple of times that we wanted to have a helper recursive function. With the string index, but we'll worry about that later. Okay, so going back to my walkthrough, the section has at least 1 to 3 characters. Okay, so let's see. Resulting would have to be this. We'll call the helper function string 0. Okay, so for the current section would be
Okay.
I guess I definitely need to do at least. Let's see. Yeah, I guess this is where I meant that I would be stuck at. It's like I know I have to compute section by section, but then when it comes to like actually processing a certain section, there are certain conditions that I need to have when traversing through the string, because it could be length of 4 or length of 12.
Okay, you know what I'm gonna do? I'm gonna show you how I do the problem, and I want you to do a comparison between what you're doing and what I'm doing. All right?
Okay.
I'm gonna do exactly what you did. I'm gonna the way I'll describe it is I'm gonna grab 1, 2, or 3 elements at a time. Grab 1, 2, or 3 elements at a time from the string. This is a chunk. Validate the chunk to make sure. Validate the chunk with 0 to 255. If valid, then add to my current running candidate, and then recurse, continue until if my current running candidate has 4 elements in it, commit it to the answer, return. So this is the way I would like to describe my high-level algorithm, right?
So this, okay. So
Why?
Is this what you would how you would describe it compared to the top section here where I said build up a section and process string from left to right? Is that?
Well, because it's kind of like it's a little bit easier to understand, and it's a little bit resembles a little bit more code. Why? I can step through this, right? So let's say my current running candidate, whatever we call it, is going to be essentially just a list of strings, or integers, ints. Yeah. Essentially, it's going to be a list of ints, or I guess this is a good way to describe it, right? And so this way I have some way of actually tracing through what I'm doing, right? So let's say I have 190.168.122, right? My current running candidate list doesn't have 4 elements in it, right? So I'm going to grab 1, 2, or 3 elements at a time, right? So let's say I grab 1. This is my chunk, right? I'm going to add this one. It's valid. This chunk is valid in my 0 to 255, right? I'm going to add this element.
Yeah.
And then I'm going to recurse with the chunk removed. So now I go into my so let's say I have 1 here, right? And so then now I'm going to go into here, and with 901682122, I don't have 4 elements, so then I'm going to grab 1, 9, and then recurse in, right?
Yeah.
And then da-da-da. You see where I'm going with this? Is that...
Yeah.
Yeah, is that now I have an ability to, like, verify my idea. 0, and then 6, let's say 1 now. And then, so now I'm at 1901, right? I'm going to check to see if my candidate has 4 elements in it. But it's like, okay, well, looks like I forgot to say, hey, yeah, and needs to be at end of string. Or in this case, our string needs to be nothing, right? And if this is a case...
Okay.
And if it is, then we're going to commit to the answer. Otherwise, we return it, right? So you can see here, like, I'm actually walking through what I'm doing and testing to make sure that I have everything together. So you see, like, how I'm able to test my idea and pseudocode like this?
Yeah, actually, like, I think once you had this, like, template, I found it a lot easier to like, to kind of walk through it, like as you did here. I guess, like, without this template, or, like, just the way I walked it through high level was just not close enough to how it would be in the code in terms of the flow. So when I actually, from the high level to when I started coding, there was like a disconnect.
Yeah, there's a huge level disconnect, and I'm trying to really nail down the reason. For me, like, the only difference between what you did and what I did was literally just this. Oops. Yeah. Was this. That's it. All I did was, like, try walking through it. And I think that, what's it called? Yeah, I think this was really the only difference. Because I did describe the exact same thing you did. I grabbed 1, 2, or 3, you see call it section, I call it chunk. I grabbed 1, 2, or 3 elements from the string. And then I validate the chunk if it's between 0 and 255, right? And then if it was valid, then I'm going to add it to my current running candidate list. And then I'm going to recurse with that chunk removed from the string. That's it. That's all I did. And then the thing is that for you, you just said you want to end up with 4 valid sections. But then to me, it's like, if you actually tried doing this exercise of like, okay, well, how are you going to form your running candidate, or how you're going to do it, then I think the answer becomes a lot more clear. So to me, this kind of says 2 things. 1, you don't have a lot of practice with recursion. And 2, you're not really able to really express the idea as like in a very simple way. Like you could probably, like you showed me that you were able to add periods. Like I get that. But then the next thing is like, okay, well, how do I translate that into something that's manageable and I can demonstrate in a call stack?
Yeah, that's something I've been struggling with even since last week. Just like being able to express, like, I think I did also mention this, like just being able to express my thoughts in a simpler way.
Yes.
Even last week, I feel like I definitely still struggle with this. Like I feel like I've gotten better in terms of like talking and like dumping out information and walking through certain examples, but just like simplifying my idea, it's still something I couldn't do pretty well.
Okay, that's fine. We're gonna spend a little bit talking about like objective. So this is what I call about thinking and expressing objectively. So the thing is that what you're doing is you're kind of saying, oh, you're describing the problem and you're describing the solution. But the thing is that there is no connection between how your solution actually solves the problem when we want to actually implement it. So that's what I mean here. So you say we want to have 4 valid sections. It's like, okay, how do we... So the question now is, how do we get there? You know what I mean?
Yeah.
It's like, okay, well, we have these 4 valid sections. So, and you have these sections. So how do we create these 4 valid sections? How do we create these 4 valid sections? That's really what it boils down to. That's the question. Like, if there's something that you don't know, then the question is, how do we is to ask ourselves that. Like, okay, well, there's something that's implicit here. There's something that we don't have the full details on. How do I get those details? And what you do is you kind of just like skip that and say, oh, it's gonna come. But all I did here was like, hey, well, in order for me to keep track of these sections, I need to keep track of a running list, right? That's all I did. It's like, okay, well, how do I create these 4 valid sections? How do I keep track of it? I'm going to create a list, and then backtrack the chunk by popping it out of the list once I recurse out of it. That's the only difference here. And so when I talk about thinking objectively, I mean that every single step here needs to be expressible. Needs to be code needs to be able to serve that idea. So what code are you going to use in order to do that? In this case, it's like, again, it boils down to okay, I have 4 valid sections. How am I going to remember each one of these sections? And how do I form these 4 valid sections? And so and then what I did was okay, well, in order for me to grab the elements from the chunk, all I did was okay, well, once I've gotten the elements from the chunk, I'm going to make a copy of the string. Now, this isn't the most efficient, but now I have a way of actually going into the next level in order to get the next chunk and the next section. All I asked is how can I get there? And I did this without writing a single line of code. And this kind of ties into a little bit of I gave up too early. And so don't give up too early. Ask the follow up. If there is something unknown, how do I get over that? How do I use code to get over what I don't know? Or create what I need to know? That's it. Or code and examples, I should say. So you see the difference between what you did and what I did?
Yeah.
Okay.
Yeah. Yeah, it's. I feel like I get the general idea. It's just actually doing it.
Mm-hmm.
It's something I still don't have a very clear idea of.
Mm-hmm. Okay, so let's actually when last 3 minutes we have left, let's actually go to your Google Sheet.
Okay.
Yeah, let's go to Google Sheets. It's gonna. I get the feeling this is gonna be very hard for you, actually. Okay, so you have 10:24 to 10:30, and then you have vacation the week. You have vacation next week from 10:31. Okay. So what I want you to do is actually go and do some of these recursion problems and array problems as well. So let's do this. Array and recursion problems in EPI. Let me see what they correspond to. Give me a sec.
Okay.
So elements of programming interview. For me it's chapter 16. But I think that you'll so that's going to be a chapter in itself. So do recursion for sure. And then arrays. So you do those 2 sections, but I want you to really think about how, if you get stuck like this, I really want you to go hammerhead. Do not give up. Go run through the exercise of what do I need to know and how can I get there. I don't care how long it takes. It can take you a good goddamn hour and a half to do a single problem. I don't want you to give up until you've used that full hour and a half.
Okay. Okay.
I don't care how long it takes. I want you to get past that barrier. I mean, of course, don't spend 6 hours on a single problem. If it's an hour and a half, put it aside. We can talk about it on Thursday. But I want you to be able to at least give it a solid effort. Literally everything you got. I don't care how long it takes. Just always. I think I have a little section in the guide oh shit, I'm stuck. What do I do? I have a section on that. So I suggest you read that.
Yeah. Okay.
Okay. So, I think this is going to be good for you. It's going to be good practice, and if you have time and you feel better, try doing chapter 7 as well on strings, because these are going to basically be very helpful as well, but I get the feeling that you are going to take up, I guess array and, actually, why don't you do this? Do array and strings first, then do recursion. Because this will be a better practice for not giving up, because if you give up, then kind of recursion kind of falls flat. So.
Okay. Okay. I only have. I did do most of string problems. I think I only have like one or two left.
Okay.
Since you told me to do strings last week and linked lists.
Yeah, so the funny thing is that this is actually a problem from the strings chapter.
Yeah, that was like the one problem like one of the 2 or 3 problems I didn't do.
Okay. Do the problems that you didn't do then.
Yeah.
And then after that,
Okay.
go straight to recursion.
Okay.
So, yeah, this is basically what I have for you. To recap, yeah, write down the solution. Write down. No, there's no magic bullets. Really, run through a lot of examples if you need. And then like after that, after you've done all that shit, and then you solve the problem, go back over it and really think about like what you could have done, or what questions you need to ask yourself in order to get to the solution faster. So that way you don't have to do all the extra unnecessary work, or how you can do your work faster. So always think about the time afterwards, but before then, just solve the problem. Okay?
Okay.
Do you have a practice diary?
I actually don't have a practice. I just have the notes I have when I practice the problems, but I don't have a practice diary.
Okay. Here I'm gonna make a copy for you. You need to keep a practice diary.
Okay.
Okay, let me make a copy of this first. Let me share this with you. Yeah, so but in it you can kind of see like, hey, this is like this is actually from one of my clients, but you can kind of see like, hey, this is all the shit I did, and this was like super hard, or this is super easy, this is what I did right, this is what I did wrong, and I want you to keep track of this. So you also time yourself, and I want to see some of these problems or some of these rows filled out by the time I see you on Thursday. Okay?
Where did you send it?
I sent it to you in the Zoom, but I can share it to you on.
Okay. I see it. I see it now.
Okay, I can send you on Discord later as well if you need it. But yeah, I want you to start filling it out. I want you to start really reflecting on what you could have done better on these problems and writing it out. Okay.
Okay.
We got a few minutes left. Any questions?
No, I think I have a lot to get through, but I don't have questions now.
That's fine. I did see you at least gave it a try to write out all your ideas. Now it's being able to try out all your ideas in order to solve a problem and not giving up too early. So we're on step 2, man.
Okay. Yeah. Okay.
Okay.
Thank you.
All right, for sure.
Appreciate it, man.
Yeah, for sure.
All right.
Take care, man.
All right. Talk to you on Thursday.
Talk to you on Thursday. Okay. All right. Well, guess that was kind of hard. Yeah, so let's answer some questions. He's going to read DDIA. Yeah, we're trying to prep him for an L4 interview. There's only a few sections in DDIA that I need him to read. But for the most part, I'm getting the feeling that this, this coding interview stuff is actually going to be pretty, it's going to be pretty difficult for him. Because now he's going from the, oh yeah, I'm going to spam leak code and try to fucking do random problems and, look at the solution, to now he's actually trying to think about problem solving, and that's going to be a very hard jump for him. So on top of that, there is a vacation that I need to keep track of. So I don't know if he's going to even be able to get through it for next week. This guy has a year of experience. I think it's like 1 to 2 years of experience. So he should be like L3, L4 borderline, but I think that I can push him like high L3 at this point. L4 is question mark, but I'm going to do my best, yeah. So, are there any other questions in chat? I know that today's coaching session did not go as well as I thought it would, but at least we're making some progress, and slow progress is better than no progress. So, if there are no other questions, I guess I'll stop the stream. Thanks for watching, guys. Tune in tomorrow because we will have another client. I am streaming every single week, Monday, Tuesday, and Thursday. So do keep an eye out for that. You can follow me on Twitter, follow me on Discord. But essentially, I will be streaming 8 p.m. Pacific Standard Time on Monday, Tuesdays, 9 p.m. On Thursdays. So with that, what's gonna make him get to L4 if he can get past this L3 stuff and do decently well on the system design? But we have a lot to get through. Not sure if he's gonna make it through, but yeah. So with that, good night, guys, and hopefully I get to see y'all tomorrow.